Okay, we are at the end of section 1.2 of Stewart's Calculus Early Transcendentals 7th edition, and we are doing the exercises. I'm going to do now exercise 8, part 1. It has two parts, even though it doesn't really say that it has two parts. Here's the second part. It says, the question says to find the expression of the quadratic function whose graphs are shown, and I drew the graphs here. Here's the first part, first graph, and here's the second graph. And for time reasons, I'm only going to do part 1 in this video, and I'll do the second graph in another video. So let's jump right into it. This is obviously the graph of a parabola. Okay, so and the equation of a parabola is generally y is equal to x squared. Okay. What Stewart hasn't even presented yet, and I'm surprised he actually put this question in the exercises. In the next section, you're going to learn about transformations with graphs, how you can change the actual graph by manipulating its formula, its equation. And this question involves transformations, and you shouldn't already know them, but I'm just surprised he put it in because he hasn't presented it yet. So anyways, transformation wise, you could also say that y is equal to a quantity x plus or minus some value k squared plus or minus some value h for height. This would be movement when you subtract or add a number to x, the argument x under the exponent, then you get a horizontal movement left to right. If you add outside, you get a vertical movement, or subtract outside, you get a vertical movement. And this a here is a constant that, when multiplied by the argument, either produces a stretch or a compression of the graph. And this will be used, and this will be used in this question, not this, because the graph isn't moving up or down. So we're not really going to use plus or minus h. We are going to use plus or minus k, and we're going to use a. So this equation was originally, here. This is just y is equal to x squared, but it moved over 3 units. So now it should be something like y is equal to a x minus 3 squared. And it's minus because horizontal translations are really funny equation-wise. You subtract to go right in the positive direction, and then you add to go left the negative direction. And there's a reason for that, but because of time I will not get into that right now. So now what we need to do, we're almost done actually, we just need to find a, the constant that produces the stretch or compression. And to do that, we have to use this right here, the point 4, 2 on the graph. When x is equal to 4 in our function, when x is equal to 4 in our function f, we'll say y is equal to f of x, because this is f. Then we get that f of x, which is 4, f of 4, we get that it is equal to 2. Right? Our output is 2 when our input is 4, according to this graph. So we use this information, and we'll use it. Let me just move this over like that. We will use it by saying that 2 is equal to f of 4. So what's f of 4? F of 4 is a. Wherever you have an x, you put a 4 minus 3 squared. Okay, that looks like kind of like a 3. Good. Oh my gosh. Yes. Okay. So now we solve for a. We do 4 minus 3, which is 1. 1 squared is 1, and 1 times a is a. So a is equal to 2. And ignore this. Sorry about that. Our equation for the graph will be y, or f of x, is equal to 2 quantity x minus 3 squared. And that describes this graph exactly. And that is the right answer to 8, part A, or part 1.